And what does Cislunar mean?
Okay, Cislunar is a term that is becoming more common because of the ambitions that we're pursuing right now. For anyone who's not familiar with it, the preface cis indicates something within, so this signifies the space within the moon's orbit. Now, generally, we look at Cislunar, we generally use the term to reference anything in Earth-Moon space. So that would include all of the space between the Earth and the Moon, plus lunar orbits of various types. Lagrange points in the Earth-Moon system can all be considered part of cislunar space. So we'll probably be using that term repeatedly today.
Okay, thank you very much. So of course, as everyone's aware, we are 9 days out from the 50th anniversary of the Apollo 11 moon landing. Momentous occasion, also a kind of a milestone. It's part of a bigger discussion and debate that's happening right now about returning to the moon. And I think today what we're going to walk through is not only the challenges that specific mission faces, but what are the bigger implications? What might that mission sort of offer in terms of bigger possibilities for exploration of the solar system and also improving life back here on Earth? So Jim, I know you have some things you want to walk through. We'll spend 10 or 15 minutes doing that. We'll get to some Q&A, and I want to let everybody on here know that we are recording this session. We will send out the slides afterward, and we'll also send a short survey so you can let us know how we're doing on these webinars and how we can make them work better for you. So without further ado, Jim, I will hand it over to you.
Okay, so as we get the first slide up, I just want to mention that a point that I hope to make throughout this presentation is that in our pursuit of our latest lunar adventures, that we should not lose sight of what comes beyond the return to the moon. That's just the first step. That's not the end game. We are needing to continue to think about how we strategize the long-term exploration development of cislunar space and beyond. So all of the people with their heads down trying to achieve this return to the moon expeditiously have to also remember that we have to answer the question of, okay, what next?
Right.
Very good. So,
okay.
Slides are ready? Okay. Let's go with the first. All right. So just to go through a timeline so everybody recognizes where we've evolved during 2019 for our lunar ambitions. March 26th, Vice President Pence made the announcement on behalf of the administration to return to the moon by 2024, which was an acceleration from NASA's plans, and Vice President Pence said, by any means necessary. And that had some people scratching their heads as to, well, what does that exactly mean, by any means necessary? A few days, or actually a couple of weeks after that announcement, Administrator Bridenstine said the first phase is speed. Anything that is a distraction from making that happen, we're getting rid of. Now, again, not clear exactly what this means, but it can cause some concern among those who are in other parts of NASA's portfolio not connected with human spaceflight. So moving on to the next bit on the timeline here. On May 13th, supplemental request was put in for FY20 to fund $1.6 billion for the Artemis program. And also at the same time, it was requested that the NASA administrator be given authority to transfer funds between accounts. Once again, what does this mean for NASA's broader portfolio if the urgency of this mission allows the administrator to make major changes in accounts? But just a day later, if we can have the next bullet, there was a Senate hearing in which Administrator Bridenstine promised the Senate committee that he would be getting his additional funding from outside of NASA, not cannibalizing other parts of NASA. Okay, so there's some reassurance for those who are in other parts of the portfolio. Next bullet, please. And we saw on June 13th a media interview in which Administrator Bridenstine made the first comments about what the total package between now and 2024 would cost, and he estimated between $20 to $30 billion spanning FY20 to 24. Now, this is an average increase of $4 to $6 billion per year beyond what NASA is already getting for its budget. And then if you subtract out the 1.6 billion that they are asking for FY20, and then just look at the next 4 years, that means that even at the low end of Bridenstine's estimate, you'd have to get about an additional $4.5 billion per year beyond NASA's current budget. So if they stick with those figures, we're looking at some very challenging budget cycles coming up. Okay, next slide, please. And let's go back and look at the what are some top-level goals. And this is my own configuration of how to phrase these things rather than anything from an official document.
Jim Betta's view of the universe?
You could say that, yes. Or at least our little corner of the universe.
Little corner, solar system anyway.
So what are we trying to do in long-term exploration and development of space? The top-level goals, as I've identified them here, are we want to expand human knowledge and human access to resources, and then we want to use that knowledge and those resources to feed our economy, expand it, to improve quality of life, and then there may actually be an opportunity for us to improve our chances for human survival if, for example, we learn techniques that would help us deflect incoming asteroids that may collide with the Earth. I mean, these are all very ambitious and long-term things to be considered as the top-level goals of our space endeavors. Now, next slide, next bullet, please. So what have we accomplished so far in using this kind of approach? Well, obviously, we've revolutionized science with all of the research that we've done and the deep space probes that we sent out and such things.
Right.
And we have literally forced the rewriting of textbooks in multiple fields.
Right.
So we've used these great new tools that space has given us and the vantage point of space to make us safer, to improve our security, to enrich us by supplementing our ability to transfer information. And we've done all of this using basically disposable hardware and systems that are designed to relay information, to give us navigational beacons, and to essentially point cameras at the Earth from overhead. So in other words, it's all been based on the collection and transfer of electromagnetic information. So we've done a lot with that. We've revolutionized the way we do things based on that. But is that it, or is there something more? Let's go to the next bullet. So what's the next plateau for our achievements? And what that will need to be is actually the physical manipulation of things in space, where we actually go and we build things. We service what we have built there. We try to harvest resources, and that would be material and energy resources in space. We clean up our mess by doing active debris removal. This kind of physical manipulation of things in space is something that's only been touched on and often in experimental or demonstration means, but it will be something that will become very routine. We also expect to have human habitation in space on a scale vastly greater than anything we've done so far. Right now, we do things on a scale of having, say, a half a dozen people on the International Space Station, and that's sum total of humanity in space at the present time. Now, how much that will expand, well, it depends on who you talk to, but we are certainly looking at something vastly greater than the handful of people that go up into space at any given time. So how do we manage that? How do we handle the logistics for something like that? How do we adapt human physiology for the requirements of space flight? Next, please. All right, so what I'm identifying on this next slide is, again, my own vision of what are the major things that NASA and its partners need to do in order to accomplish the long-term strategy of exploration and development, especially what should we be looking at from now through, say, mid-century, the next generation or two. And I've identified 5 things that I think are really critical for this. And the first one is to enable aggressive development in cislunar space. And this is consisting of a lot of the things that have been already done by NASA and other government agencies successfully in the general stimulus to societal activity, including the economy, funding or performing early stage research, things that are far from the point where they can generate a market and profits. Building or sponsoring the construction of essential infrastructure that has multi-mission applications, becoming an anchor tenant for new developments so that they can get on their feet with a little help from the government. These are all things that have been successfully approached by governments to stimulate things like transportation infrastructure, for example. So that's one of the things. Let's go to the next bullet. The 2 greatest physiological challenges that we have in long-duration spaceflight are adapting to microgravity, living in space for long periods of time in conditions that are not at all normal for those of us on Earth, and also the radiation exposure question. There has been debate on both of these issues as to how serious is this really, but from everything that I've been able to absorb over the years, I've come to the belief that these are the 2 key things that are potential showstoppers that we have to overcome if we are going to actually be living and working in space for the long haul. So we have to experiment with all kinds of countermeasures, shielding, all the things that will be needed to maintain health. Next bullet, please. Now, this is a key thing, to demonstrate that we can live off the land. If everything that we do in space is consisting totally of sending all of the supplies and things that we need from the Earth and not being able to use any local resources, then you are never going to get beyond the stage of something equivalent to an Antarctic research station. It's not going to be true settlement or routine business activity if you can't find a way to use local resources in as much as possible. So that's something that we have to get ourselves trained up on, and the best place to do it is in cislunar space, close to home. Learn the stuff in your backyard. Okay, next. All right, planetary defense and survival. I see this as having 2 parts. So, and I already mentioned one, which I think of as the outsider threat, and that is the rogue asteroid that happens to cross Earth's path and may hit us someday and do serious damage. So that planetary defense mission is something we've been talking about for a long time, but have not engaged in it to the level where we can deploy test missions yet to see how that might effectively work. So the other part of it that I see is what I like to think of as the insider threat, and that is survival here on the Earth. And we've already discovered for many years now how effective it is to have observations of various kinds that have as much scope and coverage as possible to judge what's going on in our environment, on the Earth, in the atmosphere, and what trends there are, what emergencies we might need to deal with.
Right.
This type of Earth observation is something that's brought us great benefits so far, but there are still more things that we can do to have better coverage and better information from the space systems that we have. So being better custodians of planet Earth and observing what's going on there that might pose a threat is going to be really important for us. And then the last item is a new type of science missions in which you have, first of all, in the cases when you have humans on planetary surfaces, close interaction between those humans and robots so that they act as one interactive system to do their research. And for deeper space missions, the automated missions, instead of finding all kinds of contorted ways to stick something in the nose cone of a rocket and hopefully it'll deploy properly when we get into space, actually building large probes in space to be deployed later to the outer solar system. So I see those as the 5 big challenges that NASA and its partners will have to be tackling. So let's go to the next slide. Okay, so what we have here is a list of things that are parts of the Cislunar infrastructure. Now, some of these things, we hear a lot about. The space transportation capabilities. How do we get from Earth to various orbits? How do we create habitats that people can live in for extended periods of time? And we hear less about other things here. And I guess what I'd like to emphasize with this slide is that as we focus on some of these big requirements, let's not forget all of these others, because you need a coordinated package. You can't create a couple of pieces and say you're done until you've covered things like how do we do that extraction of materials. You can identify, oh, we found a lot of water ice on the moon. That's great. That's valuable to have. But it's not automatic that we will be able to easily and economically extract it, process it, and get it to where it's useful. We still have a lot of steps to do to figure that out. The on-orbit servicing that I believe is going to be a really essential and successful thing in the next generation of space activity. Has some challenges to it as well, so all of these things, if we are going to be doing manufacturing on orbit, if we are going to be building large facilities, there's a lot that we have to concentrate on. And I should emphasize too that I've had discussions about this with Kevin O'Connell over at the Department of Commerce, and he's well aware that if his office or what his office evolves into is going to be the one-stop shop for most of what's on this list, then he's really got his work cut out for him, because they're tackling some challenges right now, like how to start to manage space traffic management duties for civil and commercial activities in space, and that's a tough challenge for that small but growing office. But Kevin recognizes that there is much more that will be required of his office, and possibly at a very fast pace. For example, if on-orbit servicing really takes off quickly, then there are going to be regulatory concerns that he will have to attend to very soon, and we'll need the resources to do that. So the general rule is that technology moves faster than policy. Right. So sometimes you're playing catch-up a lot of times you're playing catch up in the policy realm. So.
Okay.
Hey, Dave.
All right.
Dave, this is
Yeah.
Terry. Just to let you know, Matt has a couple of questions in the chat.
Yes, I see that, and we will get to those very shortly here.
Okie doke. Want to make you aware of them.
Thank you very much.
Just got one more slide before I stop talking too much. Okay, so finally, I'll just look at some of the what I've identified here as known unknowns. We have some questions that are still in need of answers, and at least in this case, we know what the questions are.
Right.
But as I've pictured here with these three inquisitive gentlemen here asking these questions, what solutions are going to be employed to mitigate the cost of access to orbit, and also to the interorbital transportation as well. The big question of how many people will routinely be needed to operate all the things that we want to do in, for starters, cislunar space. That is going to make a big difference in the logistical support that's going to be required, and will depend a lot on how much we can live off the land when we figure out how to do that. How much will be done robotically? And maybe the answer is we should be aiming to do as much as possible robotically rather than having humans in situations where they don't actually need to be. Another question, and I alluded to this before, the resource extraction, manufacturing. We've had ideas about this for decades, but we have not done all the proof of concept work yet to demonstrate how this could be done in a way that adds value sufficiently to make it an economical proposition. As I think I've appropriately attached this bubble to Buzz Aldrin, this is the kind of question he would ask. Which orbits and points in cislunar space will prove most useful for various tasks and low energy transits? So you're going to have to place things like navigation systems that go beyond GPS. And GPS was designed for navigation on Earth and is not going to be as effective on the moon. So you need navigation. You need some communications added to cislunar space. As we've seen already, the Chinese have put a communications relay on the lunar far side so they can talk to their rover that's on the far side on the surface. There's also the question of if you are moving large amounts of materials, whether you're mining or manufacturing things, and you're going to need storage in space. Where do you store these things so that they are going to be easily accessible by the transport devices that need to deliver them? And part of that's going to depend on things like if you extract materials from the moon and then you're going to process them, do you process them right there on the moon, or do you do that somehow in orbit? We have to figure those things out. And lastly, what about the geopolitical situation? Okay, who are the good partners going to be? Will there be potential adversaries out there that will kind of throw a monkey wrench into the mix? Will there be terrestrial conflict that somehow affects our behaviors on orbit? And will decision makers be considering the implications of orbital cooperation while on Earth there is conflict? Now, right now we have a situation in which we're working very well with the Russians aboard the space station. We're having some issues with them elsewhere. How will situations like that play out in the future when we're talking about more partners and a more diverse set of partners? And we just can't predict those things, but we have to recognize that they are out there.
Absolutely.
So,
okay.
All right. So, do you want to start taking the
questions? Yeah, some good questions from our friends, Mr. Armstrong, Aldrin, and Collins. And we've got some questions stacking up from the audience. Before we get to those, we would like to ask the audience a question. And so, Terry, if we could bring up the first poll. can get a little input here.
Which poll did you want?
Oh, sorry, the one about NASA's Artemis program.
There we go. All right, everybody, so if you want to just click on the little radio button, you can see we'll broadcast those results so you guys can all see what the collective thinking is.
That's right.
Results coming in. Fairly one-sided at this point.
Yes, he's quite
Very
one-sided.
So, seeing some skepticism about that timeline. Maybe they think we'll land one earlier.
Let's not get into that. All right, yes, it does seem a bit lopsided in the answers, and certainly you have a lot of things that need to happen between now and then. We haven't even started working on a lunar lander. We need to develop a new generation of lunar surface spacesuits. Those are not inconsequential things. Those are big developments, and then there's the question of that I mentioned before about the budgets. If indeed the numbers that Administrator Bridenstine quoted recently are anywhere close to accurate, this will be just like unprecedented increase in NASA's top line budget, and what are the chances that is going to happen consistently for the next 4 years in the situation that we're in today?
Sure.
That could be the biggest hurdle.
Yeah. That's quite a challenge. All right, so Brian Harvey, thank you for submitting this first question. Jim, your thoughts on the best ways to commercialize space?
Well, I've been a big believer in, as I think I mentioned earlier, that the on-orbit servicing is going to be a big new development in space. I'm less confident in space tourism. Some people think space tourism is going to be the next big thing. And certainly there has been a significant amount of enthusiasm shown for that, but the suborbital space tourism is going to have a limited window in which you're going to have participants and interest in that, and then people are going to say, okay, what's next? They want to do orbital space tourism. Well, that's not just a simple step. They say, okay, next year we'll do orbital space. No, it's not that easy. It's significantly harder, and you preferably should have some place to go, such as a private space station that could be visited. So the cost, the challenges, the risks to that are much greater, and I'm not sure how we will get through that transition from the suborbital to the orbital space tourism. So I have some skepticism about that.
Sure.
For the proposed new large LEO constellations, well, I think technologically, I think those are don't have any big showstoppers, but the management of such systems and determining which ones will come to fruition and which ones will fall by the wayside remains to be seen. We all remember back the experience in the late 90s when some things like this were proposed, and the constellations then were not even as big as what we're talking about now. But in general, in talking about cislunar development, the private sector has to become partners in this. This is not just national space agencies getting together. It has to be the commercial sector, because unlike the earliest days of the space age, the commercial sector has as much or more expertise as the government agencies do. They've developed along those lines for decades now, and they also have more resources. So you have, say, divisions of Lockheed Martin or Boeing that that have more people than all of the civil servants at NASA. You have investment dollars in the many billions. If you look at how big developments in the private sector are made, such as years ago the Alaska pipeline, that was a huge, you bet your company kind of investment. Right. So some oil companies got together and decided that this would be a profitable venture, and made massive investments, and they made it work. Right. That's the kind of thing that's going to happen in the private sector. They have to get skin in the game, and they have to be convinced that there's going to be a long-term benefit to this. So okay. I guess we should move on to other questions.
Sure, and real quickly, I'll mention you talked about on-orbit servicing. If you go to aerospace.org/policy and click on papers, you will find a game changer on-orbit servicing, where we sort of analyze the maturity of that particular method and approach. Seems like a good stepping stone to that sort of local development we talked about.
Right.
All right, so next question comes from Matt Jones. How important do you think advanced deep space propulsion capabilities will be for the kinds of activities that we're talking about?
Okay, for human exploration and occupation, that's one I'll have to answer I don't know, because it's been sold, the nuclear thermal propulsion has been sold as a way to get places faster. Right. Like, we don't have to take 6 or 8 months to get to Mars, which is a good thing, but again, we're still in early stages of development for that, and ultimately, will it be something decided to be fitting for human travel in space? Now, my own picture of how we get to Mars is probably different than what most people are thinking about. I think the time to go to Mars is when we can have a pretty large spacecraft that can spin up at least part of the spacecraft for artificial gravity, so that you can do something like spin it up for full Earth gravity when you leave Earth, and then gradually wind it down so that you reach 1/3 gravity, which is the Martian gravity, by the time you get there, and then the crew is already prepared for the new gravity, and then reverse the process on the way back. Sure. But we need to do some experiments in on-orbit practice with a variable gravity facility to find out what is really the optimum. Do you need to have people traveling through space at 1G spun up in their spacecraft, or can you physiologically retain all of the health that you need by just doing half of Earth gravity, or 60% or something like that? Because the faster you spin something up, the more of an engineering challenge it becomes. So we need to do some tests, and we can do a mission like the one I just described in Earth orbit with a variable gravity facility and find out if that works. Is that helpful? So I know I've gotten off the track from Matt's question, but I'm not really sold on a big future for human travel on nuclear-powered rockets here.
Right. We jump to a question from Jamil. Do you think there's enough data about the psychological effects of spending prolonged periods in space? You talked about the effects on the human body of spending extended times in orbit. What about the psychological?
Yeah, I think that given the fact that with only a couple of exceptions, our experience goes to about 6 months, that we still have a lot more to learn, and using something like a lunar settlement, a lunar outpost, might help us to study effects of things like multi-year separations from the Earth. And remember, as you get further away from the Earth, say if you're going to Mars, and that is, communications even get harder because you'll have the time lag of the radio signals. So you can't even count on real-time communications with Earth anymore. So that is going to have an effect, I think, too. So quite a bit more to learn in that area. There had been proposals that choosing the crews for these very long missions should lean very heavily towards compatibility of the crew members. And that makes it harder to match up proper skill set with compatibility as well, and then hopefully that compatibility that they have demonstrated on Earth is not going to change radically as they go out onto the mission. We have to do trial runs of those things.
Right. David has a question about how NASA can mitigate risk with some of these high-risk investments and acting as this anchor tenant for new companies when, if things don't pan out. Your thoughts there?
Well, the investment that NASA makes, now we've come to think of NASA as an organization that builds things and goes places.
Right.
But we have to understand that the character of NASA is changing, and some of that has become very evident in the past few years as they've gotten into commercial servicing of the space station.
Sure.
And have become much more open than they used to be for development of commercial ventures that could take over things they used to do themselves. When NASA was formed, there was nobody else to do these things.
Right.
They had to do everything. They had to fund everything. That's not true anymore, and they should be selective about what they do. But when they see something that is either directly useful to themselves or U.S. government applications, or things that have been judged to be harbingers of new markets, then those things are worth investing in. There's always the argument about, we don't want to have the government choosing winners. Well, the government accounts for something like, nearly a quarter of GDP. So the government's got to choose something.
Right.
The government's a big player. I'm sorry, the government's part of the market. You can't say that they're completely severed from the U.S. or world market. The government buys a lot of stuff, and that means that there's really no crime in them being market influencers.
Sure.
You don't want this leaking to the point of favoritism for particular companies for political reasons or something of that nature. But the government has to pick something. The government has needs, and the government should be encouraging segments of the private sector to satisfy those needs.
Right. Does anybody have a question they want to jump in with on the phone? Unmute their phone and do this the old-fashioned way. No takers. Okay. Well, let's jump back up to, let's see, there's some other questions here. Any thoughts on the changes in NASA's human exploration program that happened today?
That just occurred last
Yes.
night. Just heard the news this morning, so I don't know really what to think about that yet, because there were not a lot of indications given as to exactly why this change was done at this time, other than seeming indication that it's time for fresh blood. So these the folks that have been moved out of these leadership positions have been with NASA a long time and respected characters. So
not a lot to go on at this point.
Well, as the president often says, let's see what happens.
Sure. So. Okay, let's ask our audience another question. Terry, if you could bring up the poll about people living in space. We've had a bit of discussion here about the impacts of living in space, and I'd be curious to know, what do you all out there think will be looking like in terms of an in-space population by 2040? All right. Results coming in. show folks what we've got here. It's a little bit of optimism, I guess, depending on how you define it. Majority of you thinking between 100 and 1,000. Jim, you have any thoughts there?
Well, that is interesting. So I noticed that we didn't seem to get any takers for over 1,000.
No.
Yeah, that's only a little over 20 years away. So so a lot has to happen to make that possible. So we've heard proposals for space development that have specified ideas for how many people would be living and working in space. And some of these go back decades. I sort of grew up on the Jerry O'Neill space colonies in which he was proposing orbiting colonies that that even in the early stages would have like 100,000 people, and up to 1 million people on a single space colony. More recently, we've seen that ULA has proposed something that they call Cislunar 1000, which was an effort to get to the point where there are 1,000 people living and working in space, and that's just a couple of years ago that it came up with that. We've heard Jeff Bezos talking about how he would expect to see 1 million people living in space. He does not give any precise time frame for that, but his ambition is to have these large numbers of people in various places around the solar system doing useful things. So one of the questions I've always had, though, is whether the number of people living and working in space is really a good metric. Now, we are doing this, if you go back to the goals and objectives that I talked about earlier, of increasing human knowledge and boosting our economy and things of that nature. We can do a lot of that with robotic systems, and as our robotic hardware and software systems improve, and we can build larger things on orbit, do we really need lots of people to operate all of those things? Shouldn't we be measuring things by how much value are we adding by our activities in space, regardless of how many people are involved in hands-on operation? So I'm not completely sold on the notion that number of people in space is a good metric for progress. But I do anticipate that there will be a lot more people in space, but they may stick pretty close to cislunar space for a long time to come. And that movement further out in the solar system for any significant number of people may be very far downrange.
Sure. So Jim, a lot of what you've talked about here and in other things you've written, it's the sort of the big picture of what return to the moon can acting as a springboard to further exploration. And the amount of time, you've touched on it here, the consistent development over not just 5 years, but decades that this will require for true success. We've also talked about administration priorities. How do you see a consistent, decades-long sort of progress being made when different presidential administrations have different priorities and may change or shift focus?
Yeah, we've seen that pretty much as each new administration comes in, something very significant changes in the approach, in the priorities, and the funding level. That's certainly been true very much so in recent times. So what I think we're seeing as a transition that we're going through right now, and sometimes you don't see these things when they're actually happening to you. It's only later that you come back and realize it. The period of the last few years, say from the time that the shuttle program ended in 2011, and look at what has happened, the realization that you can't be just depending on something like the shuttle for your access to orbit, and then we see more and more private sector participants jumping on board to try and provide that at a variety of levels, from small rockets to very big ones. You also see more ambitions in high precision Earth observation. Again, in the private sector, you see the incorporation of 3D printed components to speed up the process of developing space systems.
Right.
Some are proposing that 3D printing technologies will be used in space to use the materials we find there to create systems that are already in space. So as these things find more active participants, and especially outside of the government, that's how things are going to start ramping up. And we're already seeing the ambitions to put private space stations in orbit, to do a variety of things, including manufacturing and tourism and such. More space transportation, more space applications capabilities. And so we're getting to the point where we realize that it's not necessarily the way of the future to depend on government for everything. Sure. That as the private sector finds their niche and their ability to make some profit, that they will adopt these things, and that is a transition that we are living right now. That sure. and I would put, like I say, I would put 2011 as the real start of this. Much more private activity taking over things that we thought were either never going to be done or things that were only government responsibilities before. Right. So I think we're on that track already, and that government agencies, NASA certainly, but also Transportation Department, Commerce Department, are recognizing these things and saying, how can we pave the way to make this happen? How can we remove roadblocks? Right. How can we encourage or provide research investment to make these things happen?
Sure. Okay. Questions in the chat? I haven't seen anyone pop up. Or, again, you can unmute your phone and pipe up there if you like. Or I'll start asking questions, and then this thing will go right off the rails.
Oh, well, that could be interesting.
And it could be. What kind of benefits might we see back here on Earth? I think that's often when you see public discussion about NASA investments, space investments, people wonder, what's that do for me back here at home? And, beyond satellite TV and some other, other communication and entertainment-based services that people experience, now what else might they get out of the sort of burgeoning development of cislunar space?
Well, I think that, obviously those of us who are in the business recognize we're already getting a lot.
Right.
And that there is more that can be done in communications, in navigation, in remote sensing, and what's going to be improved in the long-term development of the use of space resources is to find a way to relieve pressures on things on the Earth. Now, some are big believers in the development of solar power satellites that will generate large amounts of power and beam them down to the Earth, so that we can use those to supplement what's being produced here on Earth, because a lot of people looked at the numbers about how much electricity demand is growing and growing and growing, and it's going to be hard to meet all of that. And in fact, over a 20 to 30 year period, we're talking about worldwide like trillions of dollars of investment just in power infrastructure. Well, some of that trillions of dollars could go to space-based infrastructure. Now, something like that, no single space technology is the silver bullet that's going to solve everything for everybody and everything. You're not going to say, oh, well, solar power satellites will give all the world's power. No, it's always going to be a mix. and that's going to be true of other things as well. I mean, overhead observation, you can do a lot of great stuff with satellites, but that doesn't mean that aircraft and balloons are going to go away.
Absolutely.
So I think we're going to find space technologies more and more intermingled with the existing terrestrial technologies to be able to supplement them, and they will back each other up. So did you have another question come in?
We did. We had a question come in from William about, and this is a question that I would not have thought to ask, about Earth-Moon Lagrange points for economic development.
Yeah, well, it's possible to
explain what a Lagrange point
is.
Okay.
And maybe if we could go to, I have a backup slide that shows the Lagrange points. If that's, can we make that any bigger? Let's see. Yeah.
Terry, do we just need to press this? See, we'll full screen it for a second. There we go.
Yeah, so there's a NASA depiction of the Earth-Moon system with the Lagrange points, and you can see there are 5 of them, and for anyone not familiar with that, these are relatively stable gravitational points in a two-body system. And what you can see is that L1 is between the Earth and the Moon, closer to the Moon, so that the gravity between the two is somewhat balanced. L2 is beyond the Moon. That's the position where the where the relay satellites from to allow communication to the lunar far side could be placed. There was for many years there was much discussion about L4 and L5 to put habitats there or manufacturing facilities there, and I'm thinking that it may be that storage warehouses might be something that would find a good place there. So those spots will require relatively less energy, propellant, things to do station keeping in those locations, and that's why they're useful. You can keep them in an orbit without expending a lot of fuel that needs to be constantly resupplied. Jerry O'Neill, for example, saw L4 and L5 as the locations for his space colonies. So we have to consider the fact that if you notice that the Earth, the Moon, and the L4 and 5 locations are pretty much our equilateral triangles there. So in other words, there's the same distance from the Earth to the Moon is the distance, the same as the distance from the Earth to L4 or the Earth to L5, or either one of those points to the Moon. So it's still a long way. You're still talking 250,000 miles between those locations. So there is going to be consideration of how much energy does it take to get between those two locations. But once you're there, you have the ability to stay there with a relatively small amount of station keeping. I would imagine that if we do get to the point of doing space manufacturing or processing or storage of materials extracted from the Moon or even near Earth asteroids, we may find that one or more of these Lagrange points would be great places to put those facilities, or whether they're for work being done or for storage. Because when there are transport ships that are going between different orbits in cislunar space, they're always going to be looking for the least energy trajectory. And if these spots can provide that for them, then that's all to the good. I was involved with some of our researchers out in Colorado Springs on a study for NASA that looked at a variety of lunar orbits as well, high inclination, elliptical orbits, and things like that, that would serve different purposes for communications or for transit between the Earth and the Moon. So all of those things are being explored at some level now, but would have to be tested and explored further to allow us to determine what kind of work we're going to do in what positions.
Very good. We've got about 4 minutes left at this point. If there are any other questions, again, either on the phone or the chat, please post them. In the meantime, we have one more poll. This one's about game-changing technology, and we are curious to get your input on which of these you think will have the biggest impact between now and 2040. So start weighing in. I believe you can only pick one. Oh, here they come. Pretty even so far. It's like watching a race.
Exciting, isn't it?
It's very exciting. I'm broadcasting the results here so everyone can see where everyone else is going. Like on-orbit servicing, 3D printing, and water ice harvesting are our top three. A little movement. Jim, which of these do you kind of key on?
I think I kind of lean toward this, since we put, I think we put a time limit over the next generation of it. I would say on-orbit servicing is what I would vote for. I think the water ice on the moon thing is going to be a little bit slower than some people expect, because see, we have yet to determine. I've been to some workshops about this. We have yet to determine how much we will be able to find the water ice in large contiguous masses, and how much it might be chopped up into thousands of little patches.
All right.
So you have to track all of that down, and then how do you extract it? You're not going to send up an astronaut with an ice pick. This is in locations in shaded areas on the moon, which are just a few degrees above absolute zero. So they're going to be essentially as hard as rock.
Right.
So you're going to have special machinery to do that.
Absolutely.
And then you have to transport the stuff somewhere to a processing facility to extract the oxygen, hydrogen from them. And then once you've done that extraction, you have to take those products and take them to where they're going to be used.
Right.
So there's expense at every step of the way, and new procedures to be developed. And I've heard a geologist from the Colorado School of Mines talk about how tough the terrain is around where we suspect the water is.
Right.
So that's going to be a tough thing.
It's not just sticking your cup under the dispenser.
If only we're that easy.
Maybe someday.
Yeah.
Maybe someday.
So.
Well, again, Jim, thank you so much for your time and your insights, and thank all of you for joining us. We shared Jim's short bio in the invitation we sent out, and as you saw in that bio, Jim wrote a paper on cislunar development, I believe, last year. Also,
Yes, I did.
Yes,
I have
hold it
right-
up. There
I
we
have
go.
right here.
Show and tell. Very good. Cislunar development, what to build and why. It can also be found at aerospace.org/policy. Click on papers. And Jim, you've written a couple books on lunar development and space topics as well.
Yes, I did. I looked at my first book looked at how these things help the Earth. Like what's in it for Earth.
Right.
And the second book was more of what do we need to be doing now so that we are a spacefaring society by mid-century.
Right. Very good. You may actually know what you're talking about. That's good for the sake of the event.
I'd like to think so.
Yeah,
anyway.
I would too.
But it is fun to talk about in any case.
Very much so. Well, again, thank you all very much for joining. We will be sending out a post-event survey. We will also send the slides around, and we will make this recording available in case you want to live the magic again or share with your friends and colleagues. So thank you so much. Have a great day, Jim. Thank you as well.
All right. Thanks, Dave.
Bye-bye now.
Nicely done, guys. We
Thank
can
you,
talk offline. We'll debrief.
All right.
All right. Bye.